Hello, and welcome to this presentation, Measuring Occupied Bandwidth with the Rohde and Schwarz FPC. In this short presentation, we'll show you how to make occupied bandwidth measurements using a Rohde and Schwarz FPC series spectrum analyzer. This presentation assumes a basic understanding of spectrum analyzer operation and occupied bandwidth. If you're not already familiar with these topics, you might want to watch the presentations Understanding Basic Spectrum Analyzer Operation and/or Understanding Occupied Bandwidth before continuing with this presentation. To access occupied bandwidth measurements on the FPC, first press the Measure Hard key, then press Measurement Mode and select Occupied Bandwidth. Don't forget to use Frequency to set the analyzer center frequency to the center frequency of the signal being measured. The FPC automatically calculates and displays the occupied bandwidth both numerically and in the form of two blue lines showing the limits. The channel bandwidth, standard, if applicable, and percent power are also displayed. Let's look at how we can change the default configuration of an occupied bandwidth measurement. In the vast majority of cases, occupied bandwidth measurements calculate the 99% power bandwidth, and this is the default setting on the FPC. This value can, however, be changed using percent power bandwidth. As with most spectrum measurements, there are certain parameters that should be set based on the type of signal we're measuring. We want to set the channel bandwidth to be slightly wider than the signal we're measuring, but not so wide that other signals are present within this bandwidth. For best accuracy, our resolution bandwidth should be set between 1 and 4% of the channel bandwidth. We also want our video bandwidth to be at least 3 times the resolution bandwidth, so that signal peaks are not being filtered. Since we're measuring power, the detector type should be set to RMS in most cases, but there are some standards that call for using a peak detector. The last important parameter to set is reference level. As usual, it's important that reference level be set above maximum signal power. We can set this manually or use Level Adjust to set this automatically. On the FPC, the configured channel bandwidth is used to set the span. The two values are always identical. One way of configuring channel bandwidth is to set it manually using the Channel Bandwidth button. A standard is the second way we can specify channel bandwidth. Wireless communication standards often define channel widths. After clicking on Standard, we can choose from a wide variety of predefined channels. Just select the technology type and channel width, if applicable, and then click on Load. The analyzer will then automatically configure the proper channel bandwidth. Let's summarize what we've covered. Remember that occupied bandwidth is used to measure the width of a signal in hertz. We define this width by determining the limits that contain a given percentage of the signal's total power, usually 99%. Most spectrum analyzers have an occupied bandwidth measurement mode, but to get the best accuracy within this mode, we still need to configure various parameters, such as channel bandwidth, resolution and video bandwidth, detector type, and reference level. Occupied bandwidth is then calculated and displayed automatically. This concludes our presentation, Measuring Occupied Bandwidth with the Rohde and Schwarz FPC. If you'd like to learn more about occupied bandwidth or other spectrum measurements, please see the links in the video description. Thanks for watching.